So we might have a little bit of time for review on. No, I mean, so next Monday we'll start chapter 10, and then following on the heels of that, we'll have the midterm exam. Okay. So we're going to have to go over that chapter or section 10.1, 10.2, and 10.3. We can probably do it in one day, and then we can also have a data review on the 30th, because like I said, we'll talk about it next week. I think I got it on the 5th, but I can't remember. I can't remember if the 5th is the day that it ends or the day that our test guide ends, because if they let me turn in the midterm grades on Tuesday, I can give you all that 5th too. But anyway. So let's just go through this thing here. So we're given two statements. It is fall for P, and Q is we're going walking. So they want us to put in symbolic form these three things. So how do you think we're going to do this one? It's got a negation in there, right? And what is it negating? It's negating only that statement. Is that it? All right, this one's a compound statement. It's we are going walking, and it is fall. But both of them are in the affirmative. So the first one is Q, and is what? And is that little symbol there. That's the and. Okay. Now for this one, they're going to want us to go backwards. They're giving us P or Q, which is it is fall or we are going walking. And there's really only one on there. Well, it could be one of these two, but this one says not fall, and there's no negation in here, so we're going to use the first one. Make sense? All right, here's a new P and Q. There are penguins at the zoo, and there are bears at the zoo. So they want us to fill in. This time there's just two. There are no bears at the zoo, so that's Q, negation, right? There are no bears in the zoo. And what symbol are we using there? Well, this is letting me select that. I thought in the past I tried to get it to. What is that little symbol? Which one of these we use? Double arrow. So there are no bears at the zoo if and only if there are penguins at the zoo, which is P. All right, so this one is giving us the wording. What wants to pick the wording from this? So this is if not P, then Q. So if not P is if there are no penguins at the zoo, then there are bears at the zoo. Does that one look good? If there are no penguins at the zoo, then there are bears at the zoo. All right. All right. So this is asking us to do a truth table, and it's just it's almost not a real truth table. It's just asking us to work these things out. So P or Q is just the basic one, and P or Q is always true unless you got two falses. And that's in distinction to the and, which is only going to be true when both of them are true. If you just got one false in there, does it end? And not P is just the opposite of P. Okay?
So the bottom, when you say false is always true?
Yeah, because if you're telling somebody you have to do this or that, then you only have to do one of them to not tell a lie. But the only time it ends up being not true or not a lie is when both of them are false.
Okay.
It's a good question, because the way I put them in the notes, because I don't like remembering them, but the way I put it in the notes is just that true is always true unless you got two falses. And then the conjunction is always false unless you got two trues. But that's just the basic one right there. That's the basic disjunction rule. Two trues means false. True. True false means true. False true means true. And false false means false. You got to do one or the other. Or you can do both, because that goes back to our when we were doing the Venn diagrams. They would say in there one or the other or both. They would always add that. So this is like the or both, and this is one or the other, and then this one is neither. The last one is neither. All right, so this is kind of neat because it gives you allows you to add in columns to do your truth tables. So what we need to do is we need to do what's on the inside first. I always, probably most people are going to tell you, if we're doing truth tables, you work your way out from the most complicated thing on the inside. And the most complicated thing on the inside of the parentheses is that not P. So not P is just the opposite. See that? Not P is just the opposite of P. That's all that the negation does. It just changes it from false to true and from true to false. All right, so now we've got this and the inside. So I'm going to put another thing right there. So I'm going to do this one and Q. So that's going to be looking at these two. For the disjunction, the order doesn't matter. You could rewrite the Q as well if you wanted to and put them in the same order. The only time I would encourage doing that is though is for the conditional, because the conditional is the one operation where it's important where the order is important. So now we're looking at these two and we're applying the disjunction, the or rule. So that same thing we just talked about. So as long as there's one T in there, this is true. There's the one that's false. Another true. All right. Does that look right? Let me know. I'll be glad to explain it because, as I said, I want this to be slow and to your pace because all of the folks that need to be reviewing here. And really, this is the last class we have, of review. Okay. So now, what I'm going to do is I'm going to put one right in there. In other words, the reason why I'm doing this is because I want to have that P in that order. So it's first. Because if you have to read backwards, and you're like me, I have trouble reading forwards, even if things are forward. So if I'm having to read backwards when something is dependent on order, it can get really messy. So now I'm using this and this, using that conditional rule. So this is where you got to change your mindset. The conditional rule is going to be true 3 out of 4 times. The only time it will be false is when the first one, the P or the antecedent, is true and the consequent is false. So that one's true. And here's the problem child right there. So there we go. That's the truth table for that statement right there. And I was able to I put it in 3 different columns, and that's why they say it's not graded, because you can put them in so you can do some intermediate work. All right, any questions? Well, the last 2. See, I'm using this one and that one, and I'm using the conditional rule. See, it's P. Well, sorry, it's if P, then not P or Q. So they all have to be boiled down to one column in order to use one of the rules. You can only use it on 2 columns at a time or 2 statements at a time. So that's the P right here. And this one right there is this baby, the not P or Q. So I'm just applying my conditional rule on those 2. All right, so this one's a little bit different. It's only giving us one column, or one row, and they're going to have us figure out things on just that one row. So this is R and P. In other words, it's P and R, and that's the conjunction rule. So we got to go back to the conjunction rule. The conjunction is false whenever you have a false of any kind in there. The only time it's true is you get 2 truths. So R and P, so that's got a false and a true, so that's false. Now, here's where we got to watch out, because they don't have a way for you to turn these around. So we're forced to read it backwards. This is if Q. No, I'm sorry. They do have it in right order. If Q, then R. And that's the pesky one right there, because Q is true and R is false. So that whole false statement is false. Now that we've got these 2 truths, these 2 columns, I guess you could say, it's not really much of a column, it's just only got 1 row. Then we're taking this, and we're putting it together with the double arrow rule, which is if they are the same, then it's true. So since F and F match, they're the same, then this is true. Another way to look at that if and only if thing, it really means the same thing as equivalence, because if they're the same, then it's true. But if they're false, I'm sorry, if one's false and one's true, then it's false. All right, so any questions? All right, so let's look on the next one there. The next one, is kind of filling them out as you go across. But here, they're making us figure out what A is from some of the other things. Well, I'm going to do the easy ones first. In other words, they're giving us B, so not B would be what? True. If B is false, then not B is true. If C is true, then not C is false. And they're telling us that not C or A is true. Since not C is already false, then this has to be true. Because that's the only way we can get that whole statement to be true, is if one of them is true. And we already had one false, so that one had to be true. All right, so now we're taking this one, the not B, and we're if and only if it with this one. So you can kind of erase that one out. There's no way I can really do it, but we're not using the not C because we've already used it. So we're using not B, this one. We're using that and this now, and we're using if and only if. If and only if is only true when both of them are the same, and these are both the same. They're both T's. All right. So here's another couple like that. All right, so they give us A and B. So not B is just the opposite of B, so this one is true. Now, they're telling us that not B and C is true. So the only way that can possibly happen if we've got two trues with an and. So that's true. And then now we're going to use A. If A, then this. So that's going to be true because you got true and true. All right, any questions about that one? Okay, keep me honest here. There's always a possibility that I'm missing something, but I'm trying to go slow so I don't mess anything up. But you're always free to ask anything so I can fill in the blanks for you. Okay, so how about this next one? We're given P, Q, and R, and they want not R. So if R is true, then not R is false. Now they're asking us about P and not R. So they're asking us about this one and that one, and they're asking what the value of that is with the conditional statement. And that is the one case, true, false, where this is false. Here's one we got to read backwards but thankfully they're both truths. So if R, then Q. Since both of them are true, that's true. And now we're putting these two together with the OR statement. OR is as long as we got one T in there, it's true. And there's one T in there. All right. Penguins aren't mammals, or elephants aren't reptiles. Now, they ask us to use De Morgan's law to get equivalent statement. And if you can't remember, you can go back to those notes and look. But this is the negation of penguins are animals, and this is the negation of elephants or reptiles. So what happens when we do that? Well, when we expand out to the equivalent statement, we're going to have that negation in front of everything. So it's got to be, it is not the case, one of these two. And what happens when you do that is the or becomes an and. So it is not the case that penguins are mammals and elephants are reptiles. And just to refresh your memory, I was trying to see if I can find one that writes it like we do, but I might just have to go back to the notes. Oh, here we go. So there's your De Morgan's law. They gave us not P or not Q. All right, penguins aren't mammals, or elephants aren't reptiles. So the equivalent statement is, it is not the case, and that's usually how, when you want to negate a whole statement, in a compound statement, you use something like, it is not the case, or it is false that, because you want to negate everything that comes. So, and then the or changes into an and. All right, the next one is, Jose is in art class, or he has a test today. Now, this is a little bit different than the Morgan's laws, but you can use it because they want us to have the negation of it. So we got to add the negation. So that means essentially this. They want us to find this. They're giving us All right. I just messed it up a little bit. But anyway, this right here is the negation part I'm adding because they asked us to find the negation. All right. So how can we do that? Well, we add the negation first of all, and then we're going to go ahead and use De Morgan's law, because what we're negating is essentially this. We're essentially doing this thing. So that is in this form, because they gave us the original statement about who is in an art class and he has a test today, but they said take the negation of it. So then that's let's see what they got available over there. So in this case, they've only got one. It's not the case. So there we go. It is not the case that Jose is in art class and he has a test today, because that negation, it pulls, changes the and to an or and an or to an and. Hold on a second. Hold on a second. Did I mess something up? Yeah, that's it. All right, so this one is that converse, the inverse, and the contrapositive. So we got to deal with that. Let's see. So I'll just show you from the notes these things. So you got these two things. Well, I've got it written two different ways. I like this one better, but the conditional is just the basic conditional statement, if P then Q. The converse is when you swap them around and say, if Q then P. In the inverse is if not P, then not Q. And the contrapositive is doing both. If not Q, then not P. And the conditional and contrapositive are equivalent statements. So let's see what they want us to do over there. Okay, so the converse That's where we flip them around. They give us the statement. If a letter was sent from the U.S. to Holland, that's your P. Letter was sent from U.S. to Holland is your P. Then the letter was sent overseas. So that's a conditional statement. So the converse be if we turn them around. If the letter was sent overseas, then it was sent from USA to Holland. All right, makes sense? All right, now the inverse is when we keep those things in the same order and we just throw a negation in front of them. So if a letter was not sent from the USA to Holland, then the letter was not sent overseas. Oh, okay, you're doing it in two different steps. Okay, so we're just negating it in the same order. If a letter was not sent from the USA to Holland, then the letter was not sent overseas. And then the contrapositive is where you do both. You essentially take the converse up here and then you inverse them. So not sent overseas. And this one is not sent from USA to Holland. That's the four basic ones, okay? Questions? Let's see what else we can get into here. All right, this is another one just dealing with P, Q, and R. It's got three statements. P is Goran is hiking, Q is Linda is in geometry class, and R is Monday. All right. So they want us to type it out. We got to do it. They're not letting us pick this time. So Linda is in geometry class. Q. Or now here's where you got to watch out because or if it is not Monday, I was thinking they might have had parentheses on there, but they don't. But the reason why I'm putting the parentheses is because you see they have Linda is in a geometry class in the or, so that's telling you that that's that the or is making itself the priority, and it's not hiking, so not P. Does that look right? So Linda is in a geometry class, or if it is not Monday, or if it is not or, then Goran is not hiking. Now here, the parentheses is going to be over here. So Linda is not in geometry class. If Linda is not in geometry class, now in this case, the parentheses is not really needed, but I'm going to put it anyway. Linda is not in geometry class, so that's not Q. then going is hiking, so P. And then if and only if it is Monday. All right. Does that make sense? All right. So now this is going to have us do an argument. All right. From scratch. All right, so let's go back and look at this. Let's see, is there some way to make this bigger? It looks awful small for you folks. There's a little bit bigger. And just remember, if you do need bigger, you go all the way to the right past where that green is at, all the way to the right, the green stripe, and you hit that, it'll make your full screen. All right, so we got P is the bake sale is on Friday. Q, Michael will make cookies. All right. So here's premise one. This is our argument from the book, a textbook argument. If the bake sale is on Friday, then Michael will make cookies. That's a conditional statement. Michael will make cookies, which is just a plain old statement, simple statement. Therefore, the cake sale is on Friday. Now we're going to write these in here. So this is just if P then Q, and then this one is Q. You know, we'll be watching out here because we could save ourselves some work if you recognize some things. They're still going to want us to do the truth table, though. So if Michael is, if P, then Q, and then Michael will bake cookies, so that's just Q. And the conclusion is the bake sale is on Friday. All right. So they're going to want us to do it out, but this is that same argument I think that we had with Spock. But let's do it because they want us to do it. So, oh, they wrote it in there for us. Okay, I got you. Because if you change this, yeah, okay, that's neat. All right, so now we're going to have to just do it a step at a time. So, so this is the same old hashed out conditional argument. It'll always be true unless we got a true false, and it'll be the second one that's false because that's the one that's true false. All right, now, in order to put these together, there we go. So this one's going to be the insides or the left-hand side. So that's just the insides there. Now we're putting together this one with Q and we're using the and rule. So that just means if we got a true in it, if we got two trues, it's true. Otherwise, it's false. Got to have two truths when you're talking about the and. All right, and in order to make this in order, I'm going to put P over here because, like I said, I get real nervous about reading them backwards, and I invariably do it. So I'm going to write them in the right order, and now I'm using the conditional rule on these two. True, true is true. False, true is true. True, false is false. False, false is true. So there we have that same one, as I said before. This is that fallacy of the converse. So this is not a valid argument. And you can see from the truth table also, the same one that I did. Let's see what's over here. Just a minute. They're both the same kind of thing. Okay. I'll tell you what, let me do this one first, and it's sort of like the one we just did. Same format. All right, so P is Linda is at the beach. Q is Linda is wearing sandals. So that's P or Q. And then it's tell us that Linda is not at the beach. All right, so this is what they call that syllogistic thing. This one is valid because if you have P or Q, and then you take P out of the mix, then you can deduce Q. So yes, this is a valid argument. You can do in this one, like I said, they don't give you the opportunity to do a truth table, but I can guarantee you it's not always going to be a valid argument. So if you did not recognize that this was one of those valid forms, you're going to have to do the truth table. All right, I think this one is a little bit more work, so. All right, so this one's got three statements. All right, so if so, P is it is sunny. Q is Jessica's at the park. R is Jessica is having a picnic. Okay, so here's the argument. If it is sunny, then Jessica is playing in the park. That's premise one. It is not sunny, therefore Jessica is not at the park. So what do we have here? Oh, they're letting us choose it. So if P, then Q. So that one fits, but the second premise is a negation. But that's a not Q. That one is, this one says it is not sunny, so that's not P. It's not that one because the second premise is just a negation. So I think this is it. If it is sunny, no, that's an if then. This is if then, that's an or. All right. It can't be this one because the if P then Q is that first one. If it is sunny, then Jessica is at the park. It is not sunny, So it's not that one because it doesn't have a not P there. But this one has a not P. It is not sunny. Therefore, Jessica is not at the park. All right. What is it that they want us to do? Oh, okay. There's a second argument down there. I'm beginning to lose it already. All right. So, is this a valid argument? I mean, you could use the truth table, but let's go back over and look just to be sure. So see, there was that Spock argument. That's the one that's the fallacy of the converse. All right. Does that argument fit either of these? I don't think it does, but let's look. I can't show you both at the same time, but it's if P then Q, not P then not Q. So if it's written correctly, and let me just double check, if P then Q, and it is not P, therefore not Q. So no, this is an invalid argument. This is the fallacy of the inverse. So you could go through and do the truth table and that would work, but I'm trying to take us a shortcut on it. All right, so let's see the other one. All right, if it is sunny, then Jessica is at the park. That part is still the same as this one up here. So it's if P, then Q. It is sunny, therefore Jessica is at the park. So that's essentially what they call the direct argument. So if P, then Q, and P, therefore Q. So that's a valid argument because that's the one they call the direct the direct argument, or the what they call they call over here the law on this my notes the law of detachment. But we just know that if it's got that form, they just want to know if it's valid or not. You don't have to tell it which law. But that was this one here. Sometimes they call it the direct argument. And then the one we looked at that was at the top was this one. And they had an R in there, three statements, but they never used it. All right, so the next time I see y'all, we'll be starting on new stuff. So here's your last chance for any questions. So I would hopefully think, and as I've tried to put this out, right now is a good time to have finished all of your learning path and be working on that thing that I'm just showing you there, the practice test. Practice test, you can go through there, and if you miss some, you can go back on the second iteration, find out what you did wrong, and do it again, and theoretically you can get yourself 100 on it. And the 100 is not so much because it's going to count for a whole lot because it's meant to be practice. But generally speaking, people that do those practice tests do all right on the tests. So last questions. I think I got everybody here. Did Raven ever come in? Nope. And Madison? Nope. So any questions about anything? Like I said, yes. Sunday night is the last time that test is up there. So just remember, you're going to have to do the lockdown browser again. Personally, I don't really. We got it in the My Math Lab for other class. They use ProctorU for ProctorU Review, which I think works a lot better. I was kind of surprised how well it worked. You still have to show your ID and all that, but for this class, I don't see why you would need to have a lockdown browser myself, but ain't much we can do about that. All right, any questions? Come on.